I'm still not seeing it. Oh, there it goes. Okay,
great. Hi, folks. This is Noah Wardrop-Fruin. I'm the graduate director for the Computational Media program, the MS and the PhD at UC Santa Cruz. And I'm with...
Kate Compton.
And Joseph Osborne.
Who are both PhD students who are finishing up their work working with the computational media faculty. The plan is that I'll do a brief presentation and then we'll take questions from the chat. Unfortunately, YouTube requires you to register in order to say something in the chat. So if you're thinking about asking a question, please do so. Okay, so as I've already said, we're here to talk about the Computational Media Masters and PhD at UC Santa Cruz. And one question I get a lot is, what do we even mean by this term computational media? And I want to be clear that computational media is everywhere, right? When we go to the movies, we're seeing computational media. When we use our cell phones, we're engaged in computational media much of the time. When we share things with each other and communicate through social media, that's computational media. When we play games, which people do with more and more of their time and has a larger and larger influence on culture, that's all computational media. But what often doesn't happen in the discussion of computational media in the popular press and online is thinking about the history of where this all came from. Right? There's a long history, a decades-long history of research that made all this work possible. These everyday experiences possible. And you could think about that as a technological history. It's often told that way, right? Like, what were the graphics techniques that were developed at Utah that were taken up by Lucasfilm that were then became part of Pixar and so on. But those people were not just technologists, right? Those people were also artists and designers. And to tell this history, you're not just thinking about where the technology got developed. You're thinking about what were the art and design questions that motivated developing the technology? What are the art and design techniques that make it possible to use the technology? And you're also thinking about how we came to understand these possibilities. Right? Some of that understanding is understanding how the audience experience things, right? Human-computer interaction and other disciplines, including, say, dramaturgy, are focused on understanding how audiences experience things, and that's an important part of computational media. But also we're trying to understand how these forms express things, right? How ideas are embedded in these computational processes, in these design techniques, how we sometimes use them invisibly, how we can use them more consciously and ethically. We want to understand these things both for understanding our culture, because computational media increasingly shapes our culture, but also for more informed making, right? We can make things more effectively if we understand what they express and how audiences experience them. So the computational media degrees at UC Santa Cruz are designed to bring these three things together: technology development, art and design work, and interpretive work toward understanding. Computational media has been done for much of its history on the borders of other things, right? Space War was developed at MIT, not in a lab that was dedicated to trying to discover fundamental vocabulary for computer games, right? But that was there for other things, and people were passionate about discovering those possibilities. Now, more and more, we have labs and degree programs like ours that are dedicated to pushing forward our ability to make and understand computational media. An analogy might be that a lot of early work in bioinformatics was done either with lab science people reaching out towards computing, or with computing people reaching out towards lab science. But it wasn't until they were brought together that we had something called bioinformatics that really was dedicated to asking different types of questions and pursuing different types of agenda than either one would on their own. It's not one making use of the other, it's a new synthesis. Similarly, computational media brings together a lot of knowledge and methods and so on from the arts and humanities with methods and knowledge from computing, particularly computer science and human-computer interaction. So let me talk specifically just a bit about our degrees at UC Santa Cruz. There are 3 core classes. One of them is really to give you a foundation in the field. Where did it come from? How does it operate? Another is to help you design projects. It's focused on case studies, looking at how people brought together these different disciplinary concerns. And then a third is figuring out if you succeeded, right? What are the different methods ranging from arts critique to human-computer interaction to seeing how efficiently your algorithms run, right? What are the different ways you can figure out if what you were trying to accomplish in a project actually got accomplished, and maybe what else got accomplished? Then there are three expectations. One is we expect everyone knows how to program by the time they're doing their major work, right? This would be the master's thesis or the PhD dissertation. So if you need to know more about how to program, you can take computer science classes, and of course, there are other ways to learn. We expect that everyone knows something about making media. If you come into a program without a media making background, you have different classes you can take, including participating in a project group in the Digital Art and New Media MFA at UC Santa Cruz. And we expect that everyone knows how to interpret culture. And there are different ways you can pursue that if you don't know it before starting the degrees. But one of the exciting ones is that you can take classes offered by the History of Consciousness program here at UC Santa Cruz, which is, one of the most famous programs for this kind of work in the world. And then everyone takes what we call topics classes, which drill down into something in particular in computational media. Here's some example classes that we're offering for graduate students this year. Every master's student needs to take at least 2 topics courses. Every PhD student needs to take at least 4. In terms of timeline, these degrees are rather different in scale. So the master's could be completed in 3, 4, 5, 6 quarters, so 1 to 2 years. It sort of depends on your background and what you want to do, how fast you might complete. The PhD, on the other hand, can be completed in the number of years that the master's can be completed in quarters. And again, it depends on your preparation. We have PhD students come in who already have a master's from someone else. They already have a clear dissertation topic. They might be able to be done in 3 years. But a more typical timeline is one where you're finding your way to your dissertation topic and takes longer. MS students are done faster and generally are self-supported. PhD students are around longer and are generally supported by a combination of UCSC support, including things like TA-ships and outside funding like fellowships and research projects and so on. There's information about the current fees here, and given state budgets and so on, those things change over time. So it's probably better for you to look it up than for me to put something in these slides if this is going to remain useful for people in the future. One of the most key things about graduate school is that you spend a bunch of time working with faculty. So you want to go to a program that has faculty that can support the types of work that you want to do. And ideally more than one faculty member in case, the faculty member you went there to work with gets into an accident or, leaves for another institution or some other sort of thing. So I wanted to just give one slide about each of our faculty as a way of talking about the breadth of things that can be supported here. So in alphabetical order, Nathan Altice is first. Nathan is a media scholar who's probably best known for his book, I Am Error, which is a platform study of the possibilities of the Nintendo Entertainment System. He's also now studying things that cut across what we think of often as the generations in game development. So for example, he has a project studying board game adaptations of video games, including the rich history of this in Japan. He's also a sound artist and musician. His newest EP is called Apple Machine Music, where he remakes 5 famous sound art pieces using Apple's Music Memos software and turning on the auto accompaniment. And you kind of see this algorithmic collaboration between him and the source material and the Apple software. Angus Forbes does a variety of work in kind of interactive visualization and related areas. So for example, his time arcs is an interesting technique that looks at how entities relate in a temporal network, which is a very challenging thing to show. And he's shown successful uses in all sorts of areas, like phrases that people use on political blogs, or the IMDb co-star network, or a data set showing conflicting evidence in biomedical literature about protein interactions. The top image of the smaller ones is NeuroCave, where he's created both a virtual reality interface and a desktop interface so that brain researchers can interact with Connectome, which is a map of neural connections in the brain. And then down below is an example of one of his art projects. This one is called Poetry Chains, and it creates a kind of continuous dynamic remapping of Emily Dickinson's poetry, which you can interact with or watch as a video. Catherine Isbister does research in a variety of areas relating to social and emotional human-computer interaction. Her book, How Games Move Us, has been getting a lot of attention recently. It's about understanding the emotional impact of game design and how we can use that to make new kinds of experiences. YaMove is an example of a piece of technology designed to create social connection in person, and it does this through a dance battle game. And then down below, you see some examples of the fidget widgets that people submitted to her Tumblr, which is part of how she's studying how kind of playful activities, including fidgeting, have an impact in the real world, like helping people concentrate and learn and so on. Michael John, who often is referred to as MJ, is a more than 2-decade veteran of the game industry. He's worked on titles such as the original Spyro the Dragon trilogy. He's the co-creator of what you may know as the Cerny method. He was also one of the founders and the game director of Glass Lab, which is a groundbreaking collaboration between game development organizations and people who do learning science and big foundations like Gates and MacArthur and so on, that was really trying to figure out how we could not only use games for learning, but study those interventions in a more rigorous way. And he's right now the program director of our Silicon Valley professional MS in games and playable media. Sri Kurniawan tries to use computational media in a variety of ways to help people with special needs. So for example, the large image there is a set of screenshots from a mobile game that's used to reinforce the lessons of speech therapy for kids with cleft palate, who often just can't afford to go to therapy as often as would be useful. And the mobile game helps keep up the practice and reinforce the correct way of doing things between sessions. Similarly, they're working on virtual agents that help people who've had strokes do their rehabilitation work correctly, because it's hard to remember exactly how it's supposed to be done in between sessions. And again, technologies like this might point in the longer term to things that could even replace some of these kinds of therapy for people who simply can't afford the level that would be beneficial. And then down below, they're doing some initial work in virtual reality as a way to motivate people in physical therapy, and have already started to show positive results in it, the virtual reality environment leading people to push themselves further than they will in just standard therapy. Michael Matthias and I run a lab together called the Expressive Intelligence Studio. Michael's best known project might actually be the small one there on the top. He and Andrew Stern created Facade, which was the first fully realized interactive drama. And it's also the first game to ever be on the front of the arts section of the New York Times, instead of the technology section, which I find an amusing factoid. The large image is a sort of reasoning diagram from a game generator we're working on right now that tries to be able to interpret games, how they feel when you're playing them, and about the meanings that are expressed through them, and then can use that knowledge, can kind of reverse that knowledge to generate games that produce targeted feelings. It's one part of a larger project that's generating scenarios for a game about climate change. And then the smaller image on the bottom, I think is a project that Joe's involved with. No, Joe's not involved with. It's solely Adam Somerville's that uses, I think, pointwise mutual information to try to extract information from computer games to understand what roles the different objects play. And it's part of an ambitious project of Adam's where he would like to ideally be able to put in an NES ROM and then spit out new levels for that game with no additional human intervention. And I think some parts of the project are collaborations with Joe. Yeah.
Yes, we have the Venn diagram of our projects overlaps there.
Yeah, yeah.
Yes.
And Kate also has some work that is part of this lab that I'm hoping we'll have a chance to talk about later. Adam Smith is one of our newest faculty members, like Angus and Nathan. The large image here is Proof Doku, which is an example of him trying to use artificial intelligence techniques to expand the possibilities of gameplay. So here, players play a version of Sudoku, but they have to explain their reasoning, and the computer can give intelligent hints. The top smaller image is a project, Refraction, that was a game originally developed to teach students fractions, but only could use hand-created levels, which meant they couldn't be very customized to learners. And he used similar techniques to the one he's using in Proof Doku to show that you could generate levels that would, a large number of levels that had guaranteed aesthetic properties, that had guaranteed properties in terms of how they could be solved. And then with that large number of levels, you could serve up to an individual learner a level that you thought was right in their zone of proximal development. He's also someone who's interested in generative visual art and music. So the image there on the bottom is Ethereal Dial Pad, which is a 2D touch synthesizer that has been downloaded more than 10 million times. Erin Robinson Swink is the creative director in our professional MS in games and playable media. She's best known for her decade of work in indie games, including the well-known title Gravity Ghost and also Puzzlebots. Those are the two pictures there. This is me. I'm Noah Ward-Fruin. Expressive Processing is my most recent book, and it tries to bring together kind of a deep technical look at story technologies, from lab-oriented story generation to the industry's use of things like dialogue trees and quest flags and so on in mainstream games. And it tries to interpret what is possible in each of those and look at possibilities that could be informed by the strengths and weaknesses of them. I also have a history in electronic literature and game art and things like that. So the picture up above is a literary game called Screen, which is for room-sized virtual reality displays, generally called Caves. We have a portable one of those here. It's also used by Sri and a number of other researchers. And then down below is a screenshot of a project that was a collaboration with Eric Kaltman and Joe called GIST, the Game and Interactive Software Studies Toolkit, I think?
Something like that.
Something like that.
Something like that.
Yes, yeah. Where we wanted to experiment with the possibility of making, citing the state of a piece of software as powerful as right now, like citing a page of a book or a time code in a film. It was part of a larger project where we also did things like make recommendations that have been adopted by the Library of Congress for how games should be cataloged. And then I promise this is the last faculty member, Jim Whitehead, our chair. He works on generating things, and he's interested in generating things in the real world. So the large image there is a student, Jonathan Pagnuti of his, who's working on things like generating cocktails and sometimes things that are better loved by review boards like smoothies and other kinds of recipes. The top of the smaller images is a project in generating game levels for games that have themselves been generated. So how do you generate levels for a game where you don't know what the mechanics are going to be until it's just been generated? And then the bottom of the smaller images is research in trying to apply style to things. So the top are sort of regular Lego models, and then the bottom are dynamically applying a pirate style to those sorts of models. And again, the reason for kind of running through these faculty, and we're hiring 4 more faculty this year, right? The reason for talking about all the faculty we have is that I think we really can support a broad range of different types of research. And I think an important part of a graduate program is its ability to do that for you. I just want to talk about 2 other things before we get to questions. One is, this is really a picture of our real campus. I sometimes forget how beautiful the location is until I walk out my office door. And every day it just makes me happy to be here. So I think that can be a benefit. Where you are physically can really make a difference. And then also I wanted to mention just some nuts and bolts information. So the deadline for applications is January 3rd. It's a real deadline. The GRE general test is required. No specialized test is required. The application is online. The actual application and related information is at this URL. And then if you go to our department webpage, that's the URL on the bottom, you can find the official curricula and other information that you might find useful. So with that, that's the end, hopefully, of formal presenting for the information session. And I'm hoping that we will have a number of questions from the chat.
All right, we actually already do have one question. So Arjit asks what the funding is like for master's students. I'm not sure if he's referring to the professional master's or the whatever you would call the one here locally in Santa Cruz.
Right. So yeah, we both have a professional master's program over in Silicon Valley, and we have a computational media MS here on the Santa Cruz campus. So I was talking almost entirely about the one that's here on the Santa Cruz campus. And the expectation for people who are in the MS program is that they're self-funded. Sometimes there is funding. People in the masters sometimes are supported on research, or sometimes other funding comes along, but you shouldn't enter the masters with the expectation that there'll be funding from the institution. The funding will be something organized by you. And that, and part of that is because it's a so much shorter degree. The opportunity cost is a lot smaller than doing 3 to 6 years in a PhD to do 3 to 6 quarters in an MS.
Let's see. Okay, so we've got another question here from chat. Phoebe asks, what are the most important things I can do to improve my application chances in the upcoming year? Build up my portfolio, learn particular skills, etc.
From a media studies background.
Ah, okay.
Yes, thanks.
Yeah, my impression is that there are few things that matter, and they matter to different faculty in different ways. So part of how the admissions process works is that we're really looking to see, are there particular faculty that you want to work with, and particularly faculty that want to work with you? So let me talk about what I look for as a faculty member. One of the most important things to me is your portfolio, right? Are you already engaged in work, particularly for the PhD, that shows you're already ready to start making a research contribution? For the MS, I'm more interested in your potential. You don't already have to be at that point, but I'm looking to see that you're asking interesting questions, which again could be creative questions, technical questions, interpretive questions. From a media studies background, so I'll be looking at your writing if that's the main way you're doing media studies. If you're doing media studies that's expressed through video or interactive media, I want to look at that. I also am going to look very carefully at your letters of recommendation. So I think that's a really important part. You want to be working with faculty at your current institution if you're in school on pursuing research, so they can speak to you as a researcher in your letters of recommendation, or also just speak to things like your maturity, your organization, your intellectual ability, your creativity, all these kinds of things. If you're not in school, if you're in the workplace, hopefully you have people you work with who'd be willing to write you a letter, even if that means they know that you're thinking about going to graduate school. I don't care as much about things like your GRE scores, but there may be other faculty who do. So it really depends on if there's a particular faculty member you want to work with, reaching out to them and asking them what they value in the application. Frankly, I'm also not as concerned with grades because I know different institutions do grading very differently. I really am interested in your essay. I want to know why you want to come here in particular, what you hope to get from being here, who you hope to work with when you're here, what work of students or faculty here might inspire you, all those sorts of things. But again, I guess I'd say, just in terms of what you might in particular do, hopefully finding ways to follow your passion with the idea that your passion is in the same direction as the work you might want to do in graduate school. So for example, if you want to do work in graduate school that would require you to know how to program, well, one thing to do might be to dip your toe into learning to program now if it's not going to interfere with things like getting your senior thesis done if it's unrelated to programming. And I would be happy if you're someone who would want to work with me in particular, I would be happy to correspond with you about what I would suggest you do in terms of your further work. You could also contact other faculty members, and because I'm the graduate director, you can also just ask me questions more generically.
And what I found really useful when I was making the decision to apply and then doing my application was getting in touch with current PhD students in the program, or like finishing PhD students, and talking with them directly to see if it would be a good fit and what the expectations were for what you'd be doing in the program. And faculty as well, you can reach out to them. It's not like a secret or anything. It's not like blank applications.
Yeah, and I definitely +1 to the reaching out to faculty. This is my second round of grad school, and both times I reached out to the faculty that I'd be working with. Even just as I'd like to learn more about the program, but also I'd like to introduce myself to you, introduce what I'm doing, introducing the questions that I'm asking, and that way when they get your application, they remember the person that was behind it.
Yes.
And just, getting a feel for the department and the people if you can.
And if people wanted to reach out to you two, in particular as
Absolutely.
graduate students, what's the right way to message you on Twitter? Or
for me, yeah, Twitter is the best, at GalaxyKate on Twitter.
Email is best for me. I could spell out my email address. I'll post my email address in the chat.
Okay, great.
So we've got another question from Allison Buki.
Mm-hmm.
What sort of career opportunities do master's students typically have after graduating?
Right. So our goal is for the master's to be something that people can pursue who are interested in a wide range of different types of computational media work. So one way of looking at it might be that there's something you already know about that you want to bring computational media to, right? Maybe you have an undergraduate degree or experience in something like education, or maybe you're somebody who cares about community organizing and political action, or any number of other things. So one way of looking at this is you come into the master's and you gain new knowledge about computational media through it, and then you would go back into an area where you already have knowledge, and you would bring that computational media expertise to types of jobs that are in that area. But another way of looking at it is that what you want to do is computational media, right? So for example, both Kate and Joe have worked with people in industry while being in graduate school. I don't know if either of you wants to talk about it. I didn't talk about putting you on the spot, right? But different types of industry, right? Both game industry and other kinds of technology and computational media types of industry are things that students have worked with while they're in the program, and then have gone on to work in after the program. Would either of you be willing, or?
Sure. I mean, I worked at Electronic Arts before coming here. And then while here, I took a roughly 1 year leave of absence to work at Google on the chatbot team. And yeah, one of the really interesting things about this program is that while you can kind of think of it as a degree in video games, it's not. You can come here from video games, you can go into games, but there's intersections with theater, there's intersections with apps, with software, with chatbots, with machine learning. There's a really broad range of things that people tend to go to. We've had a number of PhD students go to Google. I guess I don't know many of the master's students, so I can't speak to where they've gone.
Right.
But yeah, we have good overlap in a number of industries. It's a nice kind of hub world to see the range of different applications for what we do.
And it looks like the appetite for research in a lot of big companies is increasing, whether it's Electronic Arts or Unity or some of these other, even within games only.
Google, Y Combinator.
Yeah, Amazon has a games team now that's doing stuff. So I think that showing that having a piece of paper that says, like, yes, I'm a legitimate computational media researcher, it's a special qualification. It's not typical. I wanted to mention also, while you're listing off some themes of the lab, something I don't remember seeing in the presentation before is social simulation and computational improvisation. Some of our most popular work in recent years has been this social simulation game Prom Week, or a social simulation plus improvisational theater piece called Bad News, and both did very well on festival circuits. And so if you're looking at going somewhere after graduate school, whether you believe that like having lots of festival entries and like recognized art pieces would be good for you, or whether you believe that having lots of conference and journal articles and sort of traditional like dead tree research is good for you. You'll have many options to pursue both areas. And in fact, many of my colleagues have done both.
And one thing that's true is I've been focusing on the computational media master's and PhD, and both of those degrees are oriented around the research lab culture and trying to contribute new knowledge. Whereas we also have the professional MS in Silicon Valley, and there your final project is aimed at being like a polished game. And the goal of most of the students in that program is to go professionally into the games industry or into making games in some other context, say, you know, making games for an education company or making games for a healthcare company. And we are going to be launching a new MS in Silicon Valley in serious games. The deadline for applications for both of those is in March, and they'll be having both online and in-person information sessions in 2018. So yes, there are definitely a wide range of career paths that we see people going into from both the master's and PhD here in Santa Cruz that are more research oriented. But it's not aimed at getting you a specific type of job, whereas the professional programs over in Silicon Valley are really calibrated to get you the knowledge and the portfolio and the connections that you need to get particular jobs.
One other kind of side question in the chat was how much programming do prospective students need to know, and are there certain programming languages which are preferred? My feeling is you can, if you have tools that you're comfortable in, you're welcome to use them. Occasionally a class will suggest or require a language. Generally when they do, I think it's Python, maybe very occasionally like R or something, but it's like you pick it up and you throw it away when the class is over, essentially.
And those tend to be the more computer science classes as well, which Joe and I were both here, but it was only the computer science degree. So we didn't go through the new computational media pipeline. But yeah, there's any number of a dozen languages going on at any given point in the lab. Some people do their work in HTML, CSS, Twine. Other people work in Python, in R, in declarative languages. I work mostly in JavaScript because that's what I enjoy, and I enjoy the outreach and the ease of making UI components. A lot of people are doing Unity. Yeah, it's you'll get exposed to a lot of different languages here, and people using a lot of different languages. A lot of the stuff that we make is not particularly complex. Often, and actually Squinky's work from, which was part of the Digital Arts and New Media program, they had an interactive narrative that was much more computationally complex at the beginning. They realized that it was not serving their project well, and it actually replaced most of that with human computation or human director.
Human intelligence, human creativity, yes, right.
And that's totally an okay move to make here. So it's not about the complexity, it's about the sophistication.
That's a nice way to put it. I like that.
Yeah, and in terms of what our expectations are for people who are applying, we expect people who are applying for the PhD to be ready to make research contributions. But for example, if that's more technical research, you obviously probably know how to program. If that's more human-computer interaction research, you might not know how to program, but you know other things that prepare you to contribute to research. Whereas in the MS, one of the reasons for coming to the MS program might be that you want to be prepared to do kinds of research that you're not prepared to do now. It could be a stepping stone to a PhD here or somewhere else. And then it's certainly fine to say the kind of research I really want to be doing requires programming knowledge that I don't have yet. And part of my goal of being at UC Santa Cruz is to acquire that knowledge. So do we have any more questions?
I think that's all the questions in the chat for now.
Okay. Well, I was wondering if each of you would be willing to just talk a little bit in more specifics about the research that you do and what drew you here, and maybe a little of the path that you took to that research. Is that okay to ask?
Sure.
And I think your stories could be informative to people.
All right. I'll start off and I'll head off the
Yes, that's a good idea.
I'll head off chat just because it's terribly distracting.
Absolutely.
Okay, I'm Kate Compton. I came here in 2011, so I've been here for probably far too long by now. But it's every year I've been here that I've grown as a person and intellectually. So that's been really wonderful. Yeah, so I came from electronic arts. My research is it largely grew out of the idea of the Spore Creature Creator, which is this piece of software that was made at Electronic Arts that allowed anybody to create a sort of rigged animated 3D creature. And that was wildly successful, and it had millions of users and millions of uploaded creatures, and people seemed to, we got really lovely handwritten notes about people who had considered themselves not creative, and this had shown them that they were creative in some way. So I thought that was really interesting and really powerful. So I'm taking that seed of an idea and saying, well, what does it mean for a computer to help people be creative? Specifically, how can AI or AI support help casual users? So maybe not the users who have a particular grand vision of the thing they want to accomplish or something that they're being paid to make, but somebody who is just kind of dallying with a piece of software and isn't really sure where they're going. And yeah, that's been really rewarding research. My research is called Casual Creators, which is the name of the sort of circle I'm drawing around software for casual users. And yeah, I've done a lot of different projects along those lines. I made a language called Tracery rather accidentally, which was, it's turned out to be the, oops, are we still live?
We sure don't look like it.
Did someone say something in the chat if we're at least audible?
Maybe I'll ask if we're still there.
I'm not sure how to kick it without ceasing the broadcast.
We hear you. Okay, so
okay, well, we'll just go like this.
All right, cool. I don't have to worry about making goofy faces. Yeah, so Tracery is a language that I made actually in Michael Matthias's interactive narrative class for one of the early class assignments to keep myself from having to do a pencil and paper assignment, which I didn't want to do. And that's really taken off and become, I think, probably the generative text language that's used all over the world now. Google has released a couple of products using it, one of which wasn't made by me. Yeah. Oh, I can't show my show and tell because we don't have a screen, but I've also used, so as part of my dissertation, I've been working on what are ways to explain generativity and especially interactive generators to people. And so I've made a deck of cards called the Generominos, which I'll post in chat, that you can use to help yourself or help students or help others design and kind of conceptualize how generative pipelines work. And those have also been really nicely successful. So yeah, I really like this department because it lets me kind of follow leads that I'm not sure about yet, even when those leads seem like they are not particularly in the scope of the project. But often they circle back around in interesting ways. Like a deck of cards is not usually a thing that you make for a dissertation, but it's been helpful.
Right. Another question from the chat in between maybe. Phoebe asks, is this program a good fit for someone interested more in storytelling through games rather than doing research, or are projects ever more focused on creativity than on trying to answer a particular concrete question?
Right. Well, the culture of the research university probably comes into play here. So, for example, we have faculty on this campus like Robin Hunicke, who runs the Studio Phenomena, or Michael Chemers, who's done things like dramaturgy for social robots, where their work as faculty members is in creativity and expression and so on. And in the context of our kind of research university, that's called their research, right? Their research is in new creative and expressive possibilities. So I know it seems like a weird way to answer your question, but I think the answer is yes, we really do want to support research like people who are trying to do powerful storytelling through games. And if you're doing something that hasn't been done before, which I suspect you would be, right? And doesn't mean that it wasn't done before technically. It can be along many aesthetic and creative and audience experience dimensions. If you're looking at something that hasn't been looked at before, or just looking at it in a new way, that's research in our context. So yes, that is a type of research focused on creativity that that we really do want to support. Do either of you have more to add to that?
No, just there are a lot of projects that have come through here about storytelling. Some of them are more abstract, of like what are systems to create storytelling, but a lot of them are I have a story and I want to tell that story. And yeah, we can access different kinds of stories that we want to tell. So the one that was mentioned, Bad News, is about exploring sort of a large number of generated American towns in the 1970s, all of which are different and all of which have their own stories, but they're all telling a story of what it means for a town to interact with itself, which is a story that you can't tell on a piece of paper. There was another one, another project that came out of here called Icebound, which was, you can look this up, but it's an interactive augmented reality game about interacting with the AI ghost of a dead author who is not a nice person in his life. And so the question of that research was not just, okay, technically, how do we make an augmented reality book? Technically, how do we make a book that can sort of generate itself from the choices that you're making? But why would you do that? Like, what does it mean for somebody to highlight one object or another object? What does it mean for, what sorts of things would you show to a grouchy author with some personal issues that would make him change who he is in different ways? So that was the question that was being answered by Icebound. I'm probably putting that very poorly.
I think that's really good. And I think that Erin Reed is a great example of somebody who came into the program when it was computer science and really took it in the direction of computational media and making it about media research and design research.
Right, and yeah, somebody whose background was as an author of interactive fictions, and that was the kind of question he wanted to pursue.
Yeah. Somebody had asked earlier in the chat about do you have to have a computer science degree to come here? And I was just thinking, I think most of the people that I know here, I don't know what their official degrees were, but a lot of them come from English or writerly or drama or theater backgrounds.
Right. And then there are also people like Joe who got a computer science degree but came here out of an MFA, right?
So I had an undergraduate in software engineering and computer science. And then I went to USC's Games Master's program, obtained an MFA there, and then came to Santa Cruz because I really liked the work that was being done by students like Mark Nelson or Adam Smith or Mike Traynor or Chris Lewis. And I decided I was inspired by this work and wanted to come and continue it. So the work that I do is in game design verification. So making sure that the game design that you've actually produced is what you thought that you had produced, so that there are no shortcuts in your levels, or that if there are, You can see what they are and decide if you like them. I'm interested in other interventions in the game development process too. So something that might support testers or something that might support analytics for a game after it's released. And in parallel, I work a lot with extracting game design information from games automatically. Like Adam Somerville, my colleague, together we've done work in automatically mapping game worlds and deriving character behaviors, sort of capturing those in a compact form to support, for example, taking a character from one game and putting it into a different game. Yeah, so I've been here since 2012. I've been in grad school a really long time too.
I remember when you just got here and you were the new one.
Yeah. Yeah, my son is turning 3 in 4 days, so that's I've been here a long time. And I wanted to say before this was closed that my wife and I had a child during this program. It was our first, and I could not have asked for a more supportive environment and more understanding advisors who really get that like there's no second time, there's no do-overs, and I feel like work-life balance wise, I've heard a lot of horror stories about maybe other programs or other advisors, not necessarily in our field, but in general. And I was very pleased and relieved that everybody's been very good to me in that respect.
Yeah, we have good culture here for the most part. I mean, I haven't seen, if we have a bad part, I have not been personally exposed to it. But we do talk very openly about mental health because grad studenting is a really bad marker for a variety of mental health issues, and so it's okay to talk openly about those and to deal with them as necessary and get support as necessary. So
yeah, I've never felt like I was just cheap labor or something for a research project. I've always felt like my direction, my intentions were being respected along every step of the way.
Yeah, there's also been a really nice thread in the department of when some of the members of our department would pitch projects that are like not normative computer science topics. Like we've got a lot of fiber arts interest. So we've had projects on quilting and sewing, all sorts of different things, crafting in general. And even when we had at the time an all-male faculty, there was never anybody who looked at it and said, is that really computer science? So it's been very open to like, oh yeah, no, if you cross whatever that is with computational media, I think you'll get something interesting. So there's nothing that feels off limits, which I think is like a really positive thing for me, and I think probably for a number of other people.
And just, by the way, we don't have an entirely male faculty anymore. And right now, the people who are in the Computational Media PhD, the largest group identify as women. Looks like we are not sitting on top of another question. Did you say all you wanted to say about your research, Joe? Or
I mean, I can always talk more about my research.
Or we could talk about like the town of Santa Cruz, or what do you think would be most useful for people to hear?
Yeah. Housing is very expensive, but it's very, very beautiful.
It's a pretty interesting community. It's because it's got the university and is kind of the closest beach to Silicon Valley. It supports more like restaurants and coffee shops and other kinds of culture spaces than a town of its size might, but it's still a pretty small town.
Yeah, and I like that you can go up to San Francisco and Silicon Valley for San Francisco and Silicon Valley events, and then you can come back here. Having spent a summer living in Silicon Valley, it was not. It was such a monoculture that it was not particularly good for me mentally.
Were you in Mountain View?
East Palo Alto.
East Palo Alto.
But yeah, I'm commuting down to Mountain View. But down here, you can be standing in line at the coffee shop and people are talking about, this may be a very Silicon Valley perspective, but they're talking about such different things. Not all of them are talking about their startups.
I live in San Jose, and I like it for that reason too. San Jose is also a little bit removed from the sort of excesses of Silicon Valley. And I drive down a few days a week. I have colleagues who live in San Jose who take the van pool, which the school provides, which you can like get on a list to sort of go down at set times. And San Jose is also really nice. It's a little bit cheaper. Or if the prices are similar, the amenities are often a little better. And coming from Los Angeles, I was like very impressed by the quality of the food in San Jose. I'll say that. I'm very food motivated. So it's even without going all the way up to San Francisco, having San Jose nearby is like a nice asset.
Mm-hmm.
And then there's an airport there, so you don't need to go to SFO, for example.
Yeah.
And yeah, it's beautiful in Santa Cruz. I lived in Capitola for my first year of the program, and I was just, you know, I walk my dog and go to the beach. It was really, it's a time I wish I could go back to, but my rental turned into a condo, so I can't.
Yeah, I mean, depending on how you count it, there are 3 or 4 airports between, you know, San Francisco, Berkeley, Oakland, San Jose, you know, Monterey, Carmel, you know, et cetera. There's an awful lot of driving distance culture of different sorts. Any kind of, you know, big city support you need, like an embassy or something like that, is only as far away as San Francisco at the maximum. So yeah, I really enjoyed living in a beautiful place with clean air and a sort of supportive community, and then having access to everything that I used to have access to when I lived in New York City. The difference is, instead of getting on the subway, you do have to drive to it. So that's the unfortunate part, is that public transportation in the wider area here is not as developed as it would be ideal for it to be.
Yeah, within the areas it's okay, but moving between the areas is tricky.
That's all I had to say.
Okay, well, I think, you know, probably it's perfectly appropriate for us to end 5 minutes before the time we said we would end. So if no further question shows up in the next 30 seconds, I'd just like to say, you know, thanks to everyone who tuned in live. For those who are watching it archived, I hope it was useful to you. And yeah, I'm excited about our program, and I hope that it can be a good place for some of you.
And can do email and get in touch.
Yeah.
And we are very happy to talk to prospective students.
And if we're not the sort of people that have the particular interests or lifestyles or like questions that you would like answered, we can also forward you along to people who do.
Mm-hmm. Great. All right. Well, thanks again, everyone.
Goodbye.
Bye.
Bye.